Welcome to the third installment of the Hybris video series. My name is Stefan Elmerthaler. I'm a PhD student at the Leipzig University, and today I will give an overview about the newest advancements in Abstract Dialectical Frameworks and Argumentation Theory. But before we start, I will introduce the research team at the Leipzig University, which consists of Gerd Prefka, the head of our group, Jakob Runge, a bachelor student who is working on the Diamond web interface, Hannes Strass, a postdoc who is working in general with Abstract Dialectical Frameworks, and myself, and I'm also working on Abstract Dialectical Frameworks and Diamond. So let's go to the presentation of the Diamond system for argumentation, which will consist of a short motivation of why we need this argumentation formalisms and where we can possibly use these systems. Then I will go to the background section, where I will give an overview about the theory behind abstract argumentation frameworks and abstract dialectical frameworks. In the end, we will go to the Diamond system, where I will show the web interface and give some intuition about what Diamond is. So, at first, in the whole argumentation community, there is one immensely popular framework, which is Dung's Abstract Argumentation Framework, or for short ADFs, and they are syntactically nothing more than a directed graph. And at this directed graph, each node is, so to say, an argument, and the directed edges between those arguments are attacks, which means that they are in some kind not compatible, and if the one holds, the other one cannot hold. And to express what such an abstract argumentation framework can denote, there are semantics, which are so-called extensions, and each extension is just a set of acceptable arguments, and what is accepted or acceptable is just defined by one of different or several semantics which are defined for abstract argumentation frameworks. This approach is really simple, and this is one of the most important aspects of this formalism, but due to its simplicity, there is one drawback, because it can only express the text. So if we want to express, so to say, support or some other kind of relation, like an attack only is strong enough if two arguments attacks one argument or something like that, it cannot be expressed naturally. And to get this expression possible in a native way, there were the recent improvement on Dung's argumentation framework, such that it were generalized to so-called abstract dialectical frameworks. One change about it were that the arguments are now called statements, and in general it is also possible to still visualize the framework with a graph, but it's not so direct as for Dung's argumentation framework. This is because the edges between those statements just denote that there is some kind of relationship between those statements. And how the relationship looks like is specified by the so-called acceptance condition. And this acceptance condition just specifies the status of one statement based on the status of the direct predecessor statements based on this dependency graph, so to say. So, and now is of course the question, for what do we need this argumentation? And there are some recent projects and ideas where we can use argumentation in practice. One approach is done by Thomas Gordon with the Carneades argumentation system, and this Carneades system is used for lawsuit analysis, which means that a lawsuit with a proponent and an opponent which tries to prove or disprove the guiltiness of a subject is just represented as some kind of tree structure, where the top node is the decision which should be done, and with the help of this structure it can be computed whether there is an argumentation such that the person is guilty or not. The second point is the idea of using the argumentation for discussion analysis, and this discussion analysis is used, for example, at Facebook or other social media. So if there is some discussion on Facebook whether or not something is good or bad or whatever, and there are claims in this discussion, the way of this approach is to translate this discussion into an argumentation framework, and then check whether those arguments and claims hold or do not hold together. And this is done by Francesco Doni and Paolo Torroni. They've called it the bottom-up argumentation, and is based on assumption-based argumentation. And then the third idea is to use argumentation for block discussions, which were done by Chris Reed and his colleagues, and they just wanted to use the argument interchange format to implement some kind of argumentative blocking, where you have an internet block and you can back up your comments or other block entries with arguments or attacks between arguments and so on. And we think that the way of the argumentation theory is a really nice approach for discussions or any kind of argumentation in the real world, and so we think that this is a nice application, and maybe we can also utilize Diamond and Abstract Dialectical Frameworks for it. But before we can get to Diamond, we need to have a look on the theoretical background. At first we will have a look on Dung's argumentation framework, and then we will go straight on to Abstract Dialectical Frameworks. So Dung's argumentation framework is, as already said, just a pair of a set of arguments and a set of attack relation between those arguments. And the notion of the semantics is basically defined by the notion of defense, which means that an argument is defended by a set of arguments if all attackers of this argument are attacked by this set of arguments. So, and around this notion we can now define several semantics which are common for Dung's argumentation framework. In general, they base on the conflict-free property, which means that a set of arguments is only conflict-free if and only if there are no two arguments inside it which attack each other. So, and if a set is conflict-free, we can now use additional properties we want to enforce to get different semantics. And for example, one is the admissible semantic, which means that this set is an admissible extension if and only if it defends all arguments it contains. And another example would be the complete extension, which means that it contains exactly all the arguments which it defends. And then there are some other semantics like the preferred, which means that it needs to be a subset maximal admissible extension, or the grounded, which is the subset minimal complete extension. And of course there's also, last but not least, the stable extension, which means that the stable extension, the set, needs to attack all arguments which are not in the stable extension. So, and in addition, I have also prepared an example for an argumentation framework of Dung. So we have 4 arguments, A, B, C, and D. And we see that A attacks B, C attacks D, D attacks C. So they are mutual attacking each other, and A has no attacker. So for the complete extension, we now have to check whether some set of arguments is defended or not. So, for example, just take B. We see B is attacked by A, but B is not defended against A. So B cannot be a complete extension. In the other way, we take A. A has no attacker, so it can defend against every attack, so to say, and therefore it is a complete extension. In addition, A and C together is also complete because C defends itself against D, and A and D is for the same reason also a complete extension. And those 3 are the only complete extensions for this argumentation framework, and therefore we can now also find the grounded extension, which is A, because it is the subset minimal complete extension, and the preferred extensions are the other 2. And the stable extension is, of course, in this case also the same as the preferred extensions. So, and now we can go further to abstract dialectical frameworks. Here we now have a triple of a set of statements, a set of links, and the set of acceptance conditions, where each acceptance condition is associated with exactly one statement. And those links denote some kind of dependency relation. So we can also say that one statement has different parents with respect to this dependency. And the acceptance condition is now defined as a Boolean function, which is just a mapping of the power set of all the parents to the truth values true and false. And because this is exactly the same definition as the definition of a truth table for a propositional formula, we can specify these acceptance conditions also with propositional formula, and for more convenience we will do it till now. And this is one example for an abstract dialectical framework where we have 4 statements, A, B, C, and D. And we see that we have the acceptance conditions as propositional formula attached to it. So A has the acceptance condition true, which means it holds universally. It should be accepted in all cases. And we see that B itself is supporting it, which means that B only holds if B can be accepted. And we also have the attack, which says that B attacks D, which is denoted by the acceptance condition of D, which is not B. And last but not least, we have the statement C, which has the acceptance condition A and B together, which means that A and B together support C. So both must hold such that C can be accepted. So, and now we go to the semantics. So we need to define some semantics such that we find extensions or so-called interpretations or models for abstract dialectical frameworks. And for this approach we use 3-valued logic. So we have the truth values true, false, and unknown. And an interpretation is now a function which maps from the set of statements to the 3 truth values true, false, unknown. And of course we can represent each interpretation also as a set of as a consistent set of literals. Yeah, for the truth values we can also establish an information ordering, which means that true has more information than unknown and false has more information than unknown, and in addition true and false are not comparable to each other. And if we have now two truth values, we can build the greatest lower bound with respect to this information ordering, which we call the consensus, which means those two truths, is there a consensus between those two truth values? So in the end, this results in the consensus operator, which means that true and true together is true, false and false together is false, and otherwise it is undecided or unknown. And of course, we can also generalize the information orderings for the interpretations. So, and based on this information ordering and these interpretations, we can now define a characteristic operator, which is also a function, which maps a three-valued interpretation to a three-valued interpretation. And this mapping is done in the following way, such that each acceptance condition is substituted by true or false as a truth constant, and in the case where it is undecided, where the mapping is undecided, just the variable stays at the place. And then we evaluate this acceptance condition, and if the acceptance condition is a tautology, the operator maps to true. If it is unsatisfiable, it maps to false, and in every other case, it maps to undecided. Yeah, and based on this characteristic operator, we can now define some semantics. One semantic is the grounded model of D, where we say that the grounded model is the least fixed point of gamma D. And another semantic is the two-valued model. And a model is a two-valued model if and only if it is two-valued, of course, and if the value of the statement is the same as the value of the acceptance condition of the associated statement. And we now will have a look to our example from before, where we just check how the models and the grounded model will look like. So at first we need a two-valued interpretation. So in this case we say that A, B and C are true, D is mapped to false, and now we just need to check whether this is a model or not. So A is true, and the truth value of the acceptance condition of A is also true, so this is okay. B is true, so the formula B is also true. This is also correct. For C, we have the acceptance condition A and B, which means that both are true, so the value of the formula under this interpretation is also true, so this is also acceptable and correct. And D is mapped to false, and because its acceptance condition is not B and B is mapped to true, this is also a legal interpretation, which is also a two-valued model. The second model is the model where A and D are true and B and C are false. So we still have the same properties, but it does not violate the value of the acceptance condition. So, and for the grounded model, we have the least fixed point, which means we just start with the empty set and apply the characteristic operator till we reach a fixed point. In this case, if we start with the empty set, the acceptance condition of A will evaluate to true, so we have A in the interpretation, but only with the knowledge that A evaluates to true, it is not possible to decide whether B, C or D shall be acceptable or non-acceptable. So this is the grounded model where A is mapped to true and everything else is mapped to unknown. So, and now we can go to further semantics. At first I will start with the admissible interpretation, and an interpretation is admissible for an abstract dialectical framework if and only if the information of the interpretation is equal or less the information of the interpretation which comes from one application of the characteristic operator. Intuitively, we just do not want to contain too much information in one interpretation, and therefore we use this notion that we have equal or less than information. And for our example ADF, we see that we have 16 admissible interpretations, and those interpretations are ordered by their grade of information. So we have this information ordering. At the bottom we have the empty set, and at the top we see that we have the two-valued models where each variable is mapped to true or false, and there is no undecided. So, and we can now go on to the complete interpretation, and the complete interpretation is now the case where the interpretation is exactly a fixed point for the characteristic operator. So we see that we have 3 different complete interpretations. One's the grounded model, which is A alone, and the two two-valued models we had before. And at last we have the preferred interpretation, which is just the information maximal admissible interpretation, and in this case it is the same as the two-valued models from before. So, and now we can go on to Diamond. The Diamond software system stands for Dialectical Models Encoding. Diamond is a set of ASP encodings which utilize the Potsdam answer set solving collection around CLASP and Gringo. And for easier usability, we have also developed a Python script as a command line interface, such that an ADF researcher can play around with different ADFs and get the computation of their interpretations. And in addition, we have an Eclipse Prolog program, such that we can have fast input format conversions between different input formats for abstract dialectical frameworks. Yeah, and now enjoy the presentation of our running web interface and Diamond. So here we have our web interface for Diamond, and in this web interface we use the idea from discussions in the internet. So we do have some kinds of articles, and each article is some claim or some fact or whatever can be stated, and then in a discussion several articles are taken and are related to each other in some ways, and then the web interface gives support to compute all different kinds of interpretations for this discussion, and then it helps the user to determine which conclusion shall be drawn or not. In general, this means that an article can be seen as a statement, and the discussion itself with the relations is just one abstract dialectical framework. In some cases it may be inconvenient to have to write many articles and then create a discussion, and sometimes it is just nice to import one ADF from a file. This is also possible, so you can use a file which describes one abstract dialectical framework, where we need effect for each statement. So we see statement A defines that there needs to be a statement A, statement B, C, and D. And then we need to define the acceptance condition for each statement, where we have at first the statement and then the propositional formula to determine the acceptance condition. So in this case, we would have the acceptance condition for D is the negation of B, so it's not B. In this case, we have the acceptance condition for A, which is just the truth constant true or verum. And you can also write C of F to get the truth constant falsum. And here you see how the conjunction of A and B is done for the acceptance condition of C. So, and when you have imported one ADF, or you just created a discussion, you get this graph view where the ADF is represented visually, where it is still possible to change the acceptance condition, for example, or to change a relation or add one relation. And when everything is done, it is possible to evaluate the whole abstract dialectical framework with the help of Diamond. And when the evaluation is done, the different interpretations are presented in a graphical and nice to see way. So here we see that we have 3 complete interpretations, and the first complete interpretation is shown where A and D are in and C and B are out. And then of course we have another one where A is in and everything else is undecided, and the third one where A, B and C are in and D is out. Of course, the web interface also computes the other interpretations, like the stable or the two-valued, where we have, of course, the stable and the other preferred from before. We have also the grounded one, where only A is in. And this is a nice way to just see which statements are acceptable or not. Of course, there are several different interpretations, and from the point of view of a discussion, there should be a set of acceptable decisions or considerations where one is chosen in the end, and therefore there is this result view where all the results are presented in a list, and each user who participated in a discussion may now vote which interpretation should be the desired one or the one which shall be accepted in the end. And after the vote, this system has provided some kind of support to find the right or just one right decision based on this discussion. So at last I want to say thank you for watching the video and wish you a nice day.